pleasant day to each and everyone, especially to our instructor, Ma'am Halima A. Mantawil, Ma'am. I am Sahada B. Kanapiya, and I am going to discuss the Doppler effect. But before that, do you ever notice the raindrops making ripples on the water, or the car producing sound? Well, these are all objects emitting waves. When we say Doppler effect, it is an important phenomenon in various scientific disciplines, including planetary science. The Doppler effect or the Doppler shift describes the changes in the frequency of any sound or light wave produced by moving source with respect to an observer. Doppler effect or the Doppler shift was first proposed by Christian Johann Doppler in 1842. Doppler effect in physics is defined as the increase or decreases in the frequency of sound, light, or other waves as the source and observer move towards or away from each other. Let's take a look in the illustration below. Two people such as person A and B are standing on the road as shown below in the picture. So, if our object is moving towards a stationary observer, these clustered up waves observe at high frequency. So, therefore, the stationary observer hears a louder sound. And if the object is moving away from a stationary observer, the waves are observed at a lower frequency. Because wavelength is inversely proportional to its pitch or frequency. So bakit kaya nasabi na inversely proportional? Because the shorter the wavelength, the higher the pitch or frequency. And the longer the wavelength is, the lower the frequency. As what I have said a while ago, when the vehicles moving towards on you or moving towards on the stationary observer, the waves are more compressed and it has a high frequency. So makikita natin dito sa illustration yung vehicles na papunta sa malapit sa tao. So ang frequency dito ay nako-compress kaya and if the object is moving away from a stationary observer, the waves are observed at a lower frequency. Now, let's move to the Doppler effect equation. We have observed frequency is equal to velocity of sound waves plus or minus the velocity of observer over the velocity of sound waves plus or minus the velocity of the source times the actual frequency. While there is only one Doppler effect equation, the equation changes in different situations depending on the velocities of the observer or the source of the sound. Number 1 here, we have the source moving towards the observer at rest. Now, in this case, the observer's velocity In this case, the observer's velocity is 0. So the velocity of the observer is equal to 0 since he or she is at rest or in the stationary position. So we have the observed frequency is equal to velocity of sound waves over the velocity of sound waves minus the velocity of the source times the actual frequency. Second, source moving away from the observer at rest. Now, imagine the ambulance has passed you. The ambulance is traveling at 25 meters per second, but you are still stationary. The frequency of the sound emitted by the ambulance is 1000 Hz, and the sound waves travel with a velocity of 343 meters per second. Since your velocity is 0, we can eliminate the velocity of the observer again from the equation. But this time, the ambulance is moving away from you. So, its velocity is negative to indicate the direction. We have here the formula. We have the observed frequency is equal to velocity of sound waves over the velocity of sound waves minus negative velocity of the source times the actual frequency. So we have here observed frequency. So we have observed frequency is equal to velocity of sound waves, that is equal to 343 meters per second over 343 meters per second plus. Bakit nagiging positive na dito? Because, diba, when we multiply two negatives, then the result is positive. So we have plus 25 meters per second times 1000 Hz, that is equal to 932 Hz. The third one is observer moving toward a stationary source. Example, imagine riding in a car towards a loud block party. As you move towards the speakers, the sound waves get closer together and the frequency increases. In this case, you are moving, but the source is not. So, the velocity of the source will be equal to 0, since the source here is in the stationary position. So, the velocity of the source will be equal to 0. So, we get the following equation. We have observed frequency is equal to the velocity of sound waves plus the velocity of the observer over the velocity of sound waves times the observed frequency. The last one is observer moving away from a stationary source. Example, you pass the loud party and you are on your way to a more serene setting. Now you are moving away from the sound waves and the frequency decreases. So since you are moving away, your velocity becomes negative. So instead of adding the velocity of the observer, we can now subtract, since the velocity of the observer is negative. So we have here the formula. The observed frequency equal to the velocity of sound waves plus the velocity of the observer over the velocity of sound waves times the actual frequency. Now let's practice the given example here. Suppose you are standing on the corner of 5th Avenue and 34th Street waiting for the light to change so you can cross the street. An approaching southbound ambulance is heading your way traveling at 35 miles per hour. If we know that the frequency of the ambulance siren is 700 Hz, we can calculate the frequency of what you hear. We have the speed of sound or the velocity of the sound, that is 340.29 meters per second. The velocity of the source is 35 miles per hour or 15.6464 meters per second. And the frequency of the ambulance siren is 700 Hz. Therefore, we have the frequency is equal to the velocity of the sound waves or the speed of the sound over the speed of the sound or the velocity of sound waves plus the velocity of the source times the frequency of the ambulance. So, ito na pag-elaborate natin. Frequency is equal to 340.29 meters per second over 340.29 meters per second minus 15.6464 meter per second. So, bakit dito? Dito sa formula natin ay positive. Pag dito na ay nagiging negative. This is because it becomes negative since the velocity of the source is moving towards the observer. So, nagiging negative. Times 700, that is, it is equal to 734 Hz.